t sine t. These are horrible. This problem to actually work out is atrocious because you're looking at a product of three functions. When you do the product rule, you got to do the threefold product rule. And you can make your life a little bit easier here. Factor the t out, factor the e to the minus t out. If you're going to actually work a problem like this, smart move. Here's a life hack for you. Sorry, I'm an idiot. T e to the minus t times a cos t plus b sine t. That's the way to package this answer. Like in terms of actual calculus, this is way easier to work with. All right. All right, so there's two ways we can go for the remainder of class. I can give you more examples of the annihilator method, or I can show you the other technique that we need to know about. All right? I think that I'm going to just focus on the annihilator method. The syllabus says I might cover variation parameters today, but I think I'm not going to. Yep. Mm-hmm. Okay. So, but question, when does this method fail? Like, I'll show you an example, one where it doesn't work. This is for next time, all right? But what example am I on? 8. All right, so like, if I was up against, say, y prime prime plus y equals to, for example, secant of t. This we could not do with undetermined coefficients. Undetermined coefficients can't touch this. It is immune. All right? It is outside of the scope of undetermined coefficients. Why is that? The reason for that is that the forcing function here does not appear as the solution set in the solution set of the constant coefficient problem. This is not a function which P of D has as a solution. Right? If we think about where this is, constant, like we did at the start of class. I'm referencing the start of class, the thing I just erased up here, right? You guys tell me, what kind of functions appear as solutions to the constant coefficient problem? Do you guys remember, like, what does appear as a solution to this? I'll start us out. E to the lambda t, right? T e to the lambda t. T squared. We could be here all day, right? T squared e to the lambda t. These kinds of things, right? How about t, 1, t squared, t cubed, etc., right? What else appeared as solutions to the constant coefficient problem? Yeah. E to the alpha t cos beta t, right? E to the alpha t sine beta t. Worst yet. So basically, of course, also things like t cos t, or, God forbid, t to the 4th sine t. These are all possible solutions to constant coefficient problems. In summary, any product or sum of polynomials, exponential functions, and sines and cosines. What about cosh and sinh? Can we do cosh? What's cosh? That's what, 1/2 e to the t plus e to the minus t. Is this the solution to a differential equation? It sure is, right? To annihilate this, d minus 1. To annihilate that, d plus 1. So d plus 1 times d minus 1, acting on cosh, we get a big fat 0. I don't know if you see what I'm saying or not yet. I haven't said it plainly yet, but what I'm actually telling you is that what all you have to do to find annihilators is you have to go back to the last class and play it in reverse. You have to find like a backtrack to last class. If I could speak more words in reverse, I would use those. I don't have any memorized. I'm not Weird Al. But, oh man, yeah.
So like when it comes down to choosing an annihilator, can we kind of just like memorize like the forms of like what annihilators like eliminate what?
The best way to learn is by example. What I want to convince you of, so I'm going to answer your question, is the way to find annihilators is to use what we already know about solving differential equations and simply think backwards. So I'll start you out. If I want to find the annihilator for, say, t, think about this. Where did t come from? T came from lambda equals to 0. How many times? Not once, but twice, right? In other words, it came from the d squared y equals to 0 equation. Yeah? If we had t e to the t, that came from what? That came from d minus 1 squared acting on y equals to 0, right? That came from lambda equals to 1 repeated. That's a lambda equals to 1 repeated. So my annihilator, d minus 1 squared. What if I'm like t squared e to the 3t? This came from having like a lambda equals to 3 three-peated. Sorry, I'm an idiot. Anyway, so what my boy is here, d minus 3 cubed, yeah. Cosine t. How about cosine beta t? How do I get rid of cosine beta t? This comes from like lambda equals to plus or minus I beta, right? It came from d squared plus beta squared. That's the annihilator of cosine, beta t. What if instead of just having cosine, I had t cosine? I do d squared plus beta squared, not just once, quantity squared. If I had t squared sine beta t, same story, but this time it comes from a plus or minus beta, I beta solution three-peated, so I have a d squared plus beta squared cubed. Let me continue. How about you guys? You guys give me a function and I'll give you an annihilator. Function, annihilator. So I heard an e, what you got for me? E to the 3?
3t cosine 5t.
5t, all right, great. So where does that appear from? Thinking in terms of the lambda notation I introduced at the start of class, that's coming from lambda is equal to 3 plus or minus 5i, right? 3 plus or minus 5i is where that comes from. So using the lemma that we found at the end of class last time, I can use completing the square in reverse, and say immediately for you that the annihilator is d minus 3 squared plus 25. So this is coming from an alpha equals to 3, beta equals to 5. Remember the lemma we had last time, d minus alpha squared plus beta squared y equals to 0 had solutions what? y1 e to the alpha, I'll use t this time, cosine beta t, and y2 e to the alpha t sine beta t, yeah. So that's how that goes, yeah, just like that. Yep.
Do sine and cosine annihilate by the same thing then?
Yes, sine and cosine, exactly. What kills sine will kill cosine. Yeah, very good question. If I had e to the 3t, sine 5t, minus e to the 3t cosine 5t, if I had I have any linear combination of these two, that same annihilator would do the trick. That will kill both of these. How about somebody else? Give me another.
Log of t.
Log of t. Natural log of t is forbidden. What's that? That is not something that appears in our laundry of solutions, laundry list of solutions to the constant coefficient problem. If you had log t, you'd have to use variation of parameters, which is what I'll talk about next class. Yeah.
What about t to the third?
T to the third cosine t. We're looking at a d squared plus 1 to the fourth power. Because the only way that appears is if you have an 8th order differential equation where your characteristic equation has lambda equals to plus or minus I repeated 4 times. The first time, there's no t. The second time, you get a t. The third time, you get a t squared. The fourth time, you get a t cubed. I work backwards. How do I do this? I have a complete and working knowledge of the homogeneous problem. You need to get that too, to be efficient at this.
So the annihilator for the second one was the same thing as the top one?
Yep.
Even though it's
If I did, oh yeah, if I did t cubed cos t plus t sine t, like that, still d squared plus 1 to the fourth power. Because if it kills this, it automatically kills the lower order stuff in that same list of fundamental solutions. Yeah.
What about the square root of t?
Square root of t, great question, is forbidden. What's that?
T times I.
T times I is in another class. Because you're asking me for a complex solution. So, yeah. Although that would, in fact, kidding aside, that would be fine. You would just use d squared. You would just use d squared, but then you'd have to allow for complex coefficients. And the whole method would have to be extended to allowing for complex undetermined coefficients, which you could do. Nothing we're doing here really is disallowed with complex.
What if you had
Yeah.
a difference? I mean, not a
All right, let's do something. So how about this? What if I had t e to the minus 7t plus t squared? What would I do? Well, how would I annihilate this? What if you have, see, if you have different things, you just attack each piece separately, okay? So like to get the t, this comes from lambda equals to minus 7, right? Twice, right? In other words, it would have come from like a d plus 7 squared type differential equation, right? So I'll do d plus 7 squared. That will annihilate the first term. Not plus d cubed, because it has to kill everything. So we have to multiply them, not add them. See, because when the product of these two operators hits this, the d cubed kills the t squared. The d cubed does stuff to this, but nothing interesting. It just differentiates it to the same kind of thing. When that kind of thing hits this, it's 0. Because remember, these operators commute like we talked about last time. Oh man, I just wrote it in the same order. I'm an idiot. Trying to show you the contrast of white on white. Like that. If I had, e to the t plus 1 plus cosine t, if I had 3 things, I would do a d minus 1 for the e to the t, a d for the 1, and a d squared plus 1 for the cosine t. That would be my annihilator. All right. I hope you guys start to see the pattern. Did you start to see the pattern? All right. So I wasn't sure I was going to be on time for class today. And so I made up a bonus quiz actually for you guys. And it's worth 10 points. So I guess I should give it to you and let you earn these bonus points. Because I already had the secretary make the, oh man. Did I set it down somewhere? Aw. Phooey. Well, it's not up here. That's your stuff, right?
Yes.
All right. If you guys can wait like 30 seconds, I'll run to my office and bring it back for you guys. I'd like to collect it next class. It's just like, it's one page, it's worth 10 points, and it's just a bunch of homogeneous equations. I thought it'd be a good way for me to give you guys something to do while you're waiting for me to come. But it turns out I got here on time, so